Hi and welcome to today's webinar, How to Reduce Energy Wastage in Your Data Center. I'm Linda Broad and I'm the Community Manager for the Energy and Carbon Management Working Group here at 2 Degrees, and I'll be your host for this webinar. I'd like to introduce you to Lorie Wigle of Intel, who'll be presenting today. Just a technical point before we kick off. For today's presentations, there'll be some time to address any questions that you might have. You can submit them to me at any point by typing into the Q&A box on the bottom right-hand side of your screen and pressing send. These questions to Lorie after her presentation is finished at the end. And if you have problems with the technology or the audio during the presentation, please use the chat box on the right-hand side to send me a message. From the menu, just select send the message to the host, and I'll get to you. So that's from me, and I'm going to hand over to Lorie now for the first part of this session. Over to you, Lorie.
Thank you much. It's a pleasure to be here today to talk about what I think is a really important topic, which is energy use in data centers. I think it's important for a couple of reasons. One is because we are so dependent on data centers, and that dependence is growing on a daily basis. And provide many of the things that we're very attached to in our lives, but the corollary to that is data centers are consuming more and more energy. Estimates say about 2% of global energy can be counted to data centers. And the way I think about the talk I'm going to give you is I want to be positive about all of the things that we can do without being Pollyanna or complacent. I don't think that we want to rest on our laurels. We have lots of opportunities to make data centers better global citizens. As I get started with that, the first thing we'd like to do is talk a little bit about fundamental to computing. And for you who've interacted with people from Intel before, we have kind of a joke that every Intel person has a slide on Moore's Law in any presentation that we do. This is actually quite relevant for the conversation that we're having today. For anyone who's not familiar with Moore's Law, Gordon Moore was one of the founders of Intel, and over 40 years ago, he established this theory that every 18 to 24 months, we would be able to double the number of transistors. And the way that we do that is by incrementally advancing and sometimes revolutionarily advancing our process technology for manufacturing microprocessors and other semiconductors. And you can see here the progression of manufacturing technology from 90 nanometer to 22 nanometer, which is the current technology that we're building microprocessors on. These are really, really important advancements because every generation allows us to deliver more computing at a lower power budget. And here with this 22 nanometer generation, we see a 37% performance gain at low voltage, and we're reducing active power by over 50% given constant performance. So this is really foundational. Now, I'm a manufacturing person, and so it's kind of hard for me to relate sometimes to the notion of 22 nanometer, but to put it in the context of something that is a little bit more tangible, 100 million 22 nanometer tri-gate transistors would fit on the head of a pin. That's how small they are. But again, what matters to us is the improvement that we see in performance and in power consumption. Now, we thought it would be kind of fun to put this into terms that everybody could relate to. So we did this little exercise reading from a data sheet for a 1971 Volkswagen Beetle, and we asked ourselves, what would the result be if you applied Moore's Law to the auto industry? So compared to that 1971 car, this year, that car would drive at 324,000 miles per hour. It would get 130,000 miles per gallon, and it cost you 5 cents. So again, just a little reminder of the power of Moore's Law and what we're able to do as we advance computing technology. Now, bring us home to a real-world example in a data center. These pie charts actually come from a real data center in the United States where we looked at the age distribution, energy consumption, and performance capability of servers in that data center. And what you can see here is this is a company that has a fairly significant, about a third of the population of servers are are older. They're 2007 or earlier. And then the company clearly didn't buy much during the recession, worst of the recession in 2008 and 2009. And now about 2/3 of the infrastructure is 2 years older or less. But the interesting thing to look at here is the inverse relationship between the age of the servers, or the population based on age, and the energy consumption. So 32% of the servers, the older ones, are using 60% of the energy, and then the even more serious problem is they're only capable of 4% of the compute capacity. And so this is a really good example or point for why one of the best things that you can do to make a data center more energy efficient is to have modern servers in it. As with the next slide, I want to talk a little bit about how the compute equipment interacts with the rest of the data center facility, looking at something that we call the multiplier effect. At Intel, we have been very engaged in data center efficiency and all of the various aspects of that. One of the things that we do is we work closely with other companies in the industry and with customers and regulators on what are the actions that can have the most impact. For the last 5 years, I was the president of Climate Savers Computing Initiative. We recently merged that organization in with another organization called the Green Grid, which is focused on resource-efficient computing. And then there's a third organization called ASHRAE, which looks at all of the specifications associated with computing. All backdrop to how things interact within the data center. And so what you can see on this slide is a really great thing that you can do to improve your data center efficiency is to reduce the amount of power that you're putting into cooling it. And there are lots of ways that you could do that. But you reduce the energy associated with cooling. If you reduce by 1 watt, you reduce your overall energy consumption by 1 watt. Now look at this table on the right-hand side of the slide. Compute, I think, is obvious. That's our servers, our networking gear. Conversion refers to power conversion. So it's power supplies, voltage regulators, UPSs, power distribution units, that kind of equipment. When we reduce cooling, we don't have impact really on the other two elements in the data center. Now, on the other hand, one of the things that we focused on exclusively in Climate Savers Computing Initiative is the power delivery piece, and in particular within the computing equipment, how could we make the power supplies more efficient? And that's really important because it has a little bit, at least, of a multiplier effect. When you reduce the energy for power delivery, in other words, more efficient power supply, you save the watt that you get from the power delivery, but you also reduce your cooling load a little bit. So 1 watt saved on power delivery gives you 1.5 watts in total. Now, the highest impact thing that you can do, though, is to make your compute more energy efficient. If your server is more energy efficient, it doesn't need as much power delivery, and you can save on cooling. So 1 watt saved on computing actually saves you 3 watts because of this multiplier effect and the interaction within the data center facility. Now, Andy Grove, another of Intel's founders, used to say you can't improve something if you don't measure it. So one of the most important things that's come along in the last few years for data centers is a series of metrics associated with making them more efficient, energy efficient. The most fundamental of those metrics is something called PUE, or power usage effectiveness. And the algorithm for that is documented on the slide here. It's really pretty simple. The notion is how much power is coming into your data center facility overall. That goes in the numerator. And how much power is making its way to your IT equipment. That goes in the denominator. And so you end up with a ratio. When we started rolling PUE out and people started measuring it pretty extensively, we found, actually an organization called the Uptime Institute did a survey, and they found that the typical PUE was 2.5. It's about more than twice the energy that was required for the actual IT, the productive part of the data center, was coming into the data center. Fast forward 5 years to 2012. Their latest survey shows that the typical PUE is around 1.8, 1.89. So there's still a lot of room for improvement, but we are making strides. If you've got a really large data center operator where IT is their factory, that is the product that they're producing, you might see a PUE of 1.1, 1.2 because they've wrung every single bit of inefficiency out of the system. The other thing to notice about PUE is because of the way it's constructed, it really ends up focusing in on your building and infrastructure. So it's really very facility oriented. So next I'm going to talk a little bit about what the things are that you can do to improve your PUE, since that is the metric that a lot of us are using now for efficiency. So the first thing is really about redundancy, and this has very much to do with the way that the data center facility gets designed and what you're thinking about as you're getting it established. Redundancy can be at any level. Some companies will want actual duplicate data centers so that they can fail over to another facility in some kind of disaster scenario. But you have to, and it could go down to just the power delivery being redundant, power supplies being redundant, et cetera. How much of the facility systems, cooling, et cetera, are redundant. And the reason that this is really important is if you've over-provisioned your support systems, that affects redundancy. So it means that things can be less efficient, partly loaded power and cooling equipment, et cetera. What we want to do ideally is provide just enough redundancy. The other comment here is starting green is a lot easier than turning green. Building these things in up front is much more cost effective than trying to revise them later. And in fact, with some things like airside economizers, it's very difficult to retrofit. They have to be designed in initially so that you have the data center designed around the airflow path. So again, key takeaways here are smart redundancy in the design is critical to both first cost and operating cost, and it's very, very hard to get green if you don't start that way. Again, an example of airside economizers where you're using outside air as the primary coolant. These projects will often fail because people tried to add them afterwards, and that's very, very hard to do. We look at the next piece here, which is cooling. Can't have a really good PUE if you don't have the best approach to cooling. And the key to cooling and efficient cooling is containment. In other words, we have to separate the hot air from the cold air, have to control the airflow and prevent the two temperatures from mixing. And we also need to control the temperature where it matters, which is at the server inlet or the IT equipment itself. One of the things that we find is often done incorrectly in data centers is that the temperature sensors are in the wrong places. They're not next to the IT equipment, so the cooling system isn't really being triggered by the right temperature setting. We did an experiment in an Intel data center where we worked with IBM, HP, and Lawrence Berkeley National Labs in California on an advanced cooling engineering project. We literally used the inlet temperature sensor that's built into the servers to control the facility system, and we were able to reduce the cooling load by on the order of 30%. And it was a well-run data center. It wasn't as if it hadn't been well designed, but there's a lot of opportunity to do better linkage between the facility systems and the literal actual IT equipment. Another much best-known method is free cooling with air-water economizers. So you can do away with chillers, if not all the time, the vast majority of the time. And then the third point here, which is really important, is ARRAY, which stands for the American Society of Heating, Rating and Air Conditioning and Engineers. There's an organization that sets the temperature and humidity guidelines for data centers. They just added 2 new classes of warmer data centers. So if you can run your data center hotter, and all of the equipment providers are now working on equipment or have equipment that can go into higher temperature, higher humidity environments, that obviously reduces the cooling load. And so Intel has played a role there, as have many other companies in the industry, in expanding the ranges for equipment. Last thing here, and we touched on a little bit on the cooling slide, is the containment is really important in managing airflow. So again, keeping hot air and the cold air separate. And there are various techniques for this. The most common is hot aisle, cold aisle, some kind of barrier between the two so that they don't mingle. Other facilities will use chimneys so that the hot air goes up into an isolated environment. So you want, again, work toward this ideal temperature at the server inlet and provide just enough airflow from each containment aisle. And there's a lot of different schools out around how you control the fan speed, and you can see that laid out in a table here. In all of these things, if people are curious about papers that have been written and other information about best practices, if you can provide me an email contact, I would be happy to send references. The last thing that I wanted to talk about a little bit is cloud computing, and this has become something that is widely discussed. I mentioned back on the slide where we talked about PUE scores and 2.5 being the old normal, 1.8 more the new normal, but these companies, these cloud computing providers and internet companies down in the 1.1 and 1.2 range. That I think is an important illustration of the possible efficiency benefits of a move to cloud computing. There was a study done by Accenture and Microsoft that's highlighted here in the green cloud that says if you look at basically the same software on independent infrastructures in a standalone data center versus cloud, there's an opportunity to cut energy consumption and carbon emissions by 30% via cloud infrastructure. And some of the reasons for that are very much aligned with what I've just been going through in terms of the efficiency metrics that have been taken. It's just that with cloud operators, they're more motivated and more likely to have implemented those things. So they shut off unused equipment when it's not being used, and that includes everything from servers to switches to the little lights in the facility. They have the ability to consolidate computing loads. So using virtualization, using consolidation, they can put more load on the equipment, and that's very important in terms of improving and increasing the server utilization. And they have a tendency to be taking full advantage of Moore's law and using modern equipment, so they're getting higher performance per watt. As I mentioned, that notion of utilization. Very often in a typical data center, you'll see lots of the servers, the majority of the servers, being utilized at only 10 to 15%. Now, where people have done a lot of server consolidation, it might be better than that. But this is a really important metric because even modern servers still use a significant amount of power at idle. This bullet says 60%. That would be an older model server. We're making improvements on idle power over as well as fully loaded power. It is important to remember that even when the servers are lightly loaded, they are using power. So the extent that you can get the utilization up, that'll be much more efficient. Data centers are also much more likely to have integrated facility and compute enterprise systems that allow for a lot of monitoring and data collection, et cetera. I had an opportunity recently to work with a small cloud provider and co-location service provider on the west coast of the U.S. recently, and the operator was sharing with me a specific proof point here of looking at a comparison. This is an actual data center facility, but looking at the differences between co-location versus cloud or shared infrastructure. In the case of co-location, the total bill for this customer is $17,000 a month, and 57% of that is going to energy. If for the cloud service, their bill goes down to $10,000 a month, and only 10% of it is for energy. So that shared infrastructure really does have a big efficiency benefit. again, largely related to the things that are documented here. My last point is really, to tie it all together, I've just gone through a lot of the aspects of the PUE focus, which is the building and lighting, the infrastructure, and those are very, very important. But remember that the majority of the energy use in a data center is going to the IT equipment, and so we need to make sure that the IT equipment is energy efficient. We have a great opportunity via Moore's Law to do that, and so those are some of the things actions that can be taken right away to make data centers more energy efficient. I'd be delighted to answer any questions that have come up.
Lorie. Okay, so as I said at the start of the webinar, if you have any questions, do send them through in the Q&A box on the bottom right-hand side of your screen. So our first question that we've had through is from Edward, who says, is it more efficient to have a huge data center or a series of edge EDGE data centers to push to consumers, given the fact that more are on mobile than hardwired in an office or home?
That's actually a really, really interesting question. And in fact, I've been working with Comcast on a project to analyze the broadband network itself and how we could make it more energy efficient and what the right balance is between what happens in central facilities versus edge facilities. I think there is a lot of opportunity to move load closer, as long as we can do that efficiently. The risk that we run is that it's typically the smaller facilities where it's not a primary focus for the business that we see the inefficiencies, and so I think there's value to distributed, but it has to be architected properly.
Sorry. Question is from Adele, who says, you made an interesting point about shut-off and 60% power used at idle. Why is it that data center professionals still do not want to turn off idle equipment?
Yeah, it's funny. I think it's gotten better, but it used to be that one of the most egregious energy wasters in a data center were what people used to call zombie servers. So they were servers that were still plugged in and running, but they weren't doing any work. And people were afraid to unplug them because they just weren't 100% sure that they didn't need them. So we've made a lot of progress, like I said, on that issue. And one of the things that we've been doing in work with other elements of the industry and also the utility industry is to put incentive programs in place for people to swap out equipment. And so a big piece of those projects is always, if you're getting some kind of compensation for doing a consolidation project, you literally have to prove that you've unplugged and taken the old servers to recycling. The sort of sleep state and turning things off question is a little bit more difficult. There still is a lot of anxiety about if the server goes to sleep, will it wake up, in time. But again, I think we're making progress on that through technologies like virtualization, and we're seeing a lot of use now of moving workloads even from one server to another. So if server A is very lightly loaded and server B still has some capacity, we can move the what is running on server A to server B and then shut down server A. Now, an important element of being able to do that effectively is having a really good understanding of the workloads in the data center and when the workload is likely to increase again, so that you allow plenty of time to reopen the server so that you've got the capacity at hand when you need it. And so, particularly something like a commerce site that has predictable hours is a really good candidate for that. I'm glad somebody asked the question. Until sometimes we get frustrated because we build all sorts of power states and energy-saving functionality into our equipment, everything from processors that go in notebook computers to the server devices. And sometimes it's really hard to get people to take full advantage of those power management capabilities.
And moving on to the next question. Edward again says, people use their own data centers instead of going to the cloud due to pure cost. I can put together a small server with data core technology for serving information and possibly even fusion I/O versus the expensive cost of all Cisco, HP, and EMC gear. Do you have any comments on that?
I'm not followed that. Could you read it one more time, Lucinda?
Yeah. People use their own data centers instead of going to the cloud due to pure cost. Edward is saying that he could put together his own small server and avoid the expensive cost of going to external providers, I suppose. Do you have any thoughts on that?
Yeah, a lot of the the cloud versus private data center is it's a classic cost versus make versus buy sort of trade-off, and it's going to depend very much on the business which is the right answer. The other reason that we find that people don't, cloud computing may not be appropriate for them, may be, special security requirements. So it's very, very hard to generalize on, what is the right answer for someone. It's very business specific. I just wanted to bring up cloud because I think people do always think about the green cloud part of it, the efficiency part of it, and so hopefully that was helpful for folks.
Thanks. And we're moving on to our final question now, which is from Adele, who says, who really owns the power and cooling budgets? Is it the managers or is it IT?
That's another really, really good question. When we really started focusing on this in the 2007 timeframe, we used to talk a lot about split incentives. With the people who were planning the facility really didn't have a lot of insight into the IT equipment, and the IT people were their pattern of behavior was, to the facility people and say, I'm going to deploy another rack, without really much regard for the power cost and other issues or impacts associated with facilities. So it was very much a split situation where the facility people are paying the power bill and the IT people are making the decisions about what equipment goes into it. One of the things that's changed there, though, is we've really forced a tighter collaboration between facilities and IT because we've increased the densities of the computing gear pretty significantly. It used to be that you needed 5 kilowatts for a rack of computer gear. Now we have racks that could consume as much as 20 or 30 kilowatts, and you need a lot more planning associated with that kind of density. Now, the news is you're doing much more work. It's much more efficient, but it also means that there has to be a much tighter integration between the IT people and the facilities people.
Great, thanks, Lorie. Okay, so that brings us to the end of today's session. Thank you so much for participating in today's webinar, and a special thanks to Lorie for her great presentation. I'm going to be hosting a recording of this webinar on the Energy and Carbon Management Working Group on 2 Degrees, and I will be sending you a link to that recording probably tomorrow morning. So thanks again for joining, and enjoy the rest of your day. Bye-bye.